Hello, in this lecture we will find out the area of the green shape in three different ways. In the drawing we have rectangle ABCD. We know that AE equals to ED, BE equals to 7 units, BF equals to 9 units, angle ABE equals to theta, and also angle EBF equals to theta, and we want to find out the green area. Okay, so in the first method we will extend BE and CD until they intersect with each other. And we will define the intersection point between extended BE and extended CD as point P. This point will be defined as point P, and actually CD is one side of rectangle ABCD, therefore it is a straight line, and we extended the straight line CD by a straight line, therefore CP will be still a straight line. So I will write it down. So line segment CP is a straight line. CP is a straight line, and we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. I will write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. I will read rule number 1 again. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So we found out that CP, line segment CP, is a straight line. So if we focus on this side of the straight line CP, at point D, then the sum of the angles must equal to 180 degrees. But before that, we know that all the angles inside a rectangle are right angles, so this angle is a right angle, it equals to 90 degrees. This angle is also a right angle, and this angle is also a right angle, it equals to 90 degrees. I will repeat again. If we focus on this side of the straight line CP, then according to rule number 1, the sum of the angles on this side at point D of the straight line CP will be equal to 180 degrees. So which angles we have at point D on this side of point D? We have here angle PDE that we will define as angle X, and this angle equals to 90 degrees. So the sum of the angles on this side of point D equals to X plus 90 degrees, and it must be equal to 180 degrees. So I'll write it down. X plus 90 degrees must be equal to 180 degrees according to rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we will subtract from this equality 90 degrees, and we will get that X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. So we can substitute angle X by a right angle. That is to say, angle EDP equals to 90 degrees. It is a right angle. So actually we found out that CP is a straight line, and we also know that the opposite sides of a rectangle are parallel to each other. The opposite sides of any rectangle, and especially of rectangle ABCD, are parallel to each other. So it means that AB is parallel to CD, but we have already found out that CP is a straight line. Therefore, if AB is parallel to the straight line CD, then AB will be also parallel to the same straight line that is CP. Okay, so we can write down that AB is parallel to CP. We know that AB is parallel to CP according to the rule that the opposite sides of a rectangle are parallel to each other. AB is parallel to CP. And those two angles, they are defined as alternating angles, and they are located between the parallel lines CP and AB. Therefore, they are equal to each other according to rule number 2. I will write down rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. So I repeat on rule number 2 again. According to rule number 2, alternating angles between parallel lines are equal to each other. And we know that those two alternating angles are located between the parallel lines AB and PC, therefore they are equal to each other. That is to say, angle ABE equals to angle EPD. This angle according to rule number 2, I'll repeat again. Angle ABE equals to angle APD according to rule number 2. But we know that angle ABE, this angle, equals to theta according to what is given us in the question. So we can write down that angle ABE equals to theta, and from this equality, from this equation, we will conclude that angle PDE also equals to theta. Angle EPD also equals to theta, so I'll write it down. Angle EPD equals to theta. So this angle EPD equals to theta. In the next step, we will prove that those two right triangles congruent to each other. Okay, we will prove that the right triangle ABE, this right green triangle ABE, is congruent to the right triangle EPD. First of all, those two angles are right angles, therefore they are equal to each other. So this angle BAE equals to this angle, that is to say angle EDP, and they are both equal to theta. Okay, so angle BAE equals to angle EPD, and they are both equal to theta. We just right now proved that those two angles, they are equal to each other, they are both equal to theta. So angle ABE, this angle, equals to this angle that is actually angle EPD. And both those two angles are equal to theta. So we found out that angle ABE equals to angle EPD, and they are both equal to theta. Those two angles, they are vertex angles, therefore they are equal to each other. Angle BEA equals to angle PED. According to the rule that vertex angles are equal to each other. I will repeat again. Angle BAE equals to angle PED, according to the rule that vertex angles are equal to each other. And it is given us in the question that AE equals to ED. AE here it is given us in the question that AE equals to ED. So AE equals to ED according to what is given us in the question. Again, AE equals to ED according to what is given us in the question. So we actually proved that those two right angles can go into each other according to angle side angle rule. I'll write it down. We proved the triangle ABE congruent, this is the sign of congruent, to triangle EPD according to angle side angle rule. I will repeat again. Triangle ABE is congruent to triangle EPD according to angle side angle rule. So what is angle side angle rule? Angle side angle rule states that if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included in another triangle then the triangles congruent to each other. I will read the rule again, according to angle side angle rule. If two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included in another triangle, then the triangles congruent to each other according to angle side angle rule. Okay, and actually here in our drawing we proved that those two angles and the side that included between them, that is to say side AE in triangle ABE, the green triangle, congruent correspondingly to those two angles and side ED that is included between them in triangle EPD. Therefore, we proved that those two right triangles congruent to each other according to angle side angle rule. Okay? And because of the fact that those two triangles congruent to each other, we will conclude that BE equals to EP. I repeat again, we will conclude that BE equals to EP according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say BE and EP, will be equal to each other. But we know that BE equals to 7 units. 7 units. It is given us in the question. So we can write here that BE equals to 7 units, and from this equation we get that EP also equals to 7 units. EP also equals to 7 units. So we can write here that EP equals to 7 units, and in the next step we will define the quadrilateral EBFD in the green shape as the area. We will define the area of quadrilateral EBFD as Y. Again, the area of quadrilateral EBFD, the green quadrilateral, is defined as Y. That is to say, its area equals to Y. The area of quadrilateral EBFD equals to Y according to our definition. And we will also define the area of the green right triangle ABE as X. And we know that the green area, so according to our definitions, the area of the green shape will be equal to X plus Y. So I write it down. The area of the green shape will be equal to X plus Y according to our definition. I'll repeat again. The area of the green shape will be equal to X plus Y according to our definitions. And we know we have already proved that triangle ABE is congruent to triangle EPD. Those two triangles congruent to each other. Therefore, they also, because of the fact that they congruent to each other, therefore they also have the same areas. And because of the fact that the area of the green right triangle ABE equals to X, then the area of triangle EPD will be equal also to X. And the area of triangle PBF, now triangle PBF will be also equal to X plus Y. I'll repeat again. The area of triangle PBF, this is the sign of the area. It means the area of triangle PBF also equals to X plus Y. So the area of the green shape equals to X plus Y, and the area of triangle PBF also equals to X plus Y. So the area of the green shape equals to the area of triangle PBF. Therefore, we can find out the area of triangle PBF, and in this way we will find out also the area of the green shape, because they have exactly the same areas. That is to say, their areas is X plus Y. So we'll find out the area of triangle PBF, and in this way we will find out the area of the green shape. Okay? As you can see from the drawing, the triangle PBF, this triangle PBF is an isosceles triangle. Why? Because it has two angles that are equal to each other, those two angles, they are both equal to theta, so you can write down the triangle PBF is an isosceles triangle. Triangle PBF is an isosceles I'll repeat again. Triangle PBF is an isosceles triangle because of the fact that it has two angles that are equal to each other. Those two angles, they are both equal to theta. And as you can see from the drawing, point E is the middle point of side BP. Side BP, it is actually the base of triangle PBF, and point E is the middle point of side BP, of the base of triangle PB, that is to say of BP. Why? Because BE equals to 7 units and EP also equals to 7 units. So point E is the middle point of side BP, that is also the base of the isosceles triangle, triangle PBF. And we also have rule number 3. According to rule number 3, the median in an isosceles triangle, the median to the base in an isosceles triangle is perpendicular to the base. I write it down. So I'll read rule number 3 again. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have an isosceles triangle, triangle ABC, so this triangle, triangle ABC, is an isosceles triangle. Why? Because it has two angles that are equal to each other. Those two angles that are both equal to theta, therefore triangle ABC is an isosceles triangle, and the base of the isosceles triangle is BC. So if from the vertex A we will draw median to the base BC, then the median, according to its definition, bisects the base BC into two equal parts. So if the touching point between the median and the base BC is point O, then we know that BO equals to OC. So if BO equals to X, then OC will be also equal to X. That is the definition of the median, that it bisects the base. So BO equals to OC. And according to rule number 3, the median is not only bisects the base, but it is also perpendicular to the base BC. That is to say, this angle is equal to 90 degrees and this angle also equal to 90 degrees. I will repeat again. The median AO to the base BC in an isosceles triangle, triangle ABC, it is perpendicular to the base BC, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So we can implement rule number 3 in our drawing. Here in our drawing we have the isosceles triangle, triangle PBF, and the median FE this median, the median FE to the base PB of the isosceles triangle PBF, it is not only bisects the base PB into two equal parts, that is to say PE equals to 7 units and EB also equals to 7 units, but it is also perpendicular to the base PB, that is to say this angle is a right angle, it equals to 90 degrees, and this angle, it is also a right angle, it equals to 90 degrees. So the median FE to the base PB is perpendicular to the base, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, this is according to rule number 3. And because of the fact that this angle is a right angle, it equals to 90 degrees, then the green triangle, triangle BEF, this green triangle is a right triangle. So in the right triangle, right green triangle, triangle BEF, according to Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. the hypotenuse in this green right triangle is BF because it is in front the right angle. So the square of the hypotenuse is BF square. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to EF square plus EB square. I'll repeat again. According to the Pythagoras theorem, in the right triangle, triangle BEF, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BF square equals to EF square plus EB square. But we already know that BF equals to 9 units, therefore BF square is 9 square. 9 square is 81, and it equals to EF square. EF is the missing variable, so we will leave it as it is, EF square plus EB square. EB is 7 units, so EB square is 7 square. 7 square is 49. So in conclusion, we got that 81 equals to EF square plus 49. We will subtract 49 from this equation, equation number 1, and we get that 81 minus 49 is 32. So we got that EF square equals to 32. Here we will take a root out of this equation, equation number 1, and we will get that EF equals to the square root of 32. We know that 32 is 16 times 2, so I write it down. And the square root of 16 is 4, I write it down. In conclusion, we got that according to equation number 1, EF equals to 4 times square root of 2 units, so we can write here that the median EF equals to 4 times square root of 2 units. So now it is very easy to find out the area of the isosceles triangle, triangle PBF. That is also the green area. It equals to, its area equals to the area of the green shape. The area of any triangle, and especially the area of triangle PBF, according to the formula for the area of any triangle, it equals to the base of the triangle times the height to the base over 2 I will repeat again. The area of the isosceles triangle, triangle PBF, equals to the base of the triangle times the height to the base over 2 So the base of triangle PBF is PB. The height to the base is EF because the height must create 90 degrees with the base, and you can see that EF creates 90 degrees with the base BP, so the height is EF over 2. In conclusion, we found out that the area of the isosceles triangle PBF equals to PB times EF over 2. So the area of the isosceles triangle PBF equals to PB. PB equals to 7 plus 7. That is to say, it equals to 14 units times EF. EF equals to 4 times square root of 2 units, all divided by 2. So, in conclusion, we found out that the area of the isosceles triangle PBF equals to 14 times 4 times square root of 2 over 2. Here 14 over 2 is 7, so I write it down. So we found out that the area of isosceles triangle PBF equals to 7 times 4 times square root of 2. 7 times 4 is 28, so I'll write it down. (28) times square root of 2 square units You should remember that the area of the isosceles triangle PBF, it is also the area of the green shape. They have the same areas. So we can write down that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay? So, we finished with method 1. In the next step, I will present to you how to find out the area of this green shape in another way, in a second method. We know that the opposite sides of a rectangle are parallel to each other. That is to say, AB is parallel to DC, because ABCD is a rectangle. But if AB is parallel to DC, then AB will be parallel also from part of BC, that is FC. FC is part of DC, therefore if AB is parallel to DC, then AB will be also parallel to FC. So AB is parallel to FC, and we have rule number 2 that alternating angles between parallel lines are equal to each other. Those two angles are defined as alternating angles, and they are located between the parallel lines FC and AB. Therefore, they are equal to each other according to rule number 2. So if this angle is theta plus theta is 2 theta, then this angle will be also equal to 2 theta. So this angle equals to 2 theta according to rule number 2 that alternating angles that are located between parallel lines are equal to each other. Those two alternating angles are located between the parallel lines FC and AB, therefore they are equal to each other. And because of the fact that this angle is 2 theta, then this angle will be also equal to 2 theta. Okay? And we also know that all the angles inside the rectangle are right angles. So this angle is a right angle. It is one out of 4 angles of rectangle ABCD, therefore it is a right angle. This angle, it is also a right angle, it equals to 90 degrees. And this angle, it is also a right angle, that is to say it equals to 90 degrees. Okay, so here I will draw again. First of all, we will define AE as x. AE equals to x according to our definition. It is given us the question that AE it is given us the question that AE equals to ED. AE equals to ED. So if AE is x, then ED will be also equal to x. So we will focus on this right green triangle, triangle ABE. I will copy it in the new page, and we will analyze this right triangle. So AE equals to x according to our definition. Angle ABE is theta according to what is given us in the question. And it is also given us in the question that side BE equals to 7 units. BE equals to 7 units. And this angle, it is a right angle. So triangle ABE is a right triangle. Therefore, sinus theta will be equal to x over 7. You can see from the drawing, ABE is a right triangle, therefore sinus theta equals to x over 7. We will focus on the right triangle, triangle BFC. On the right triangle, triangle BFC, you can see from the drawing that on the right triangle, triangle BFC, sinus 2 theta. Okay, first of all, we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to BC. But AD equals to x plus x, that is to say, AD equals to 2x. AD equals to 2x, and we know that AD equals to BC, therefore BC will be also equal to 2x. Okay, BC equals to 2x. So, in this right triangle BFC, sinus 2 theta will be equal to 2x over 9. Sinus 2 theta equals to 2x over 9. But we have the trigonometric identity that states that sinus 2 theta equals to 2 sinus theta cosine theta. According to this trigonometric identity, we can substitute sinus theta by 2 sinus theta cosine theta. We'll do it now, and we will get that sinus 2 theta is 2 sinus theta cosine theta. And according to equation number 2, sinus 2 theta equals to 2x over 9. According to equation number 1, sinus theta equals to x over 7. So we can substitute sinus theta in equation number 2 by x over 7, because sinus theta equals to x over 7 according to equation number 1. So we'll do it now, and we'll get that 2 times sinus theta is x over 7 times cosine theta, it equals to 2x over 9. Okay, so here we have 2x on both sides of equation number 2, so 2x will get cancelled. What is left after we cancelled 2x from equation number 2? What is left? It is actually cosine theta over 7 equals to 1 over 9. Here we will multiply equation number 2 by 7 in order to get the value of cosine theta. And we will get that the value of cosine theta according to equation number 2 is equal to 7 over 9. So we found out that cosine theta equals to 7 over 9. I'll write it again here. Cosine theta equals to 7 over 9. So what is the meaning of cosine theta equals to 7 over 9? It means that we have a right triangle with one angle that equals to theta. The side that is near angle theta will be equal to 7 units, and the hypotenuse of this right triangle will be equal to 9 units. And the side that is in front of angle theta, this side, we will define it as S, and we will find out the value of S according to the Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, 7 square plus S square equals to 9 square. 7 square is 49. 9 square is 81. We'll subtract 49 from this equation, and we will get that S square equals to 41 minus 49 is 32. We will take a root out of this equation, and we will get that S equals to the square root of 32. S equals to the square root of 32. 32 is 16 times 2, so I'll write it down. And the square root of 16 is 4. So in conclusion, in total we got that S equals to 4 times square root of 2. Here S equals to 4 times square root of 2. So what is the value of sinus theta? You can see here that the value of sinus theta, it is actually 4 times square root of 2 over 9. We found out that sinus theta equals to 4 times square root of 2 over 9, and cosine theta equals to 7 over 9. So I write it in a new page. We found out that cosine theta equals to 7 over 9, while sine theta equals to 4 times square root of 2 over 9. According to equation number 1, sinus theta equals to x over 7. You can see it from this drawing. Sinus theta equals to x over 7. So we actually will find out the value of x. According to equation number 1, sinus theta equals to x over 7. But we have already found out that sinus theta equals to 4 times square root of 2 over 9, so we can substitute sinus theta in this equation number 1 by 4 times square root of 2 over 9. Sinus theta equals to x over 7. We will multiply this equation number 1 by 7, and we will get that x equals to 7 times 4 is 28 times square root of 2 over 9. So we found out that x equals to 28 times square root of 2 over 9. So we can write here that x equals to 28 times square root of 2 over 9. Here also x equals to 28 times square root of 2 over 9. and AD equals to x plus x, that is to say AD will be equal to 56 times square root of 2 over 9, and we know that AD equals to BC. AD equals to BC because the opposite sides of a rectangle are equal to each other. That is to say, BC also will be equal to 56 times square root of 2 over 9. Here you can see, if you relate to the right green triangle ABE, this green right triangle, cosine theta equals to AB over 7. Cosine theta equals to AB over 7. So I'll write it down. Cosine theta from triangle ABE, the right triangle ABE, we can see that cosine theta equals to AB over 7, but we have already found out that cosine theta equals to 7 over 9. So we can substitute cosine theta by 7 over 9. 7 over 9 equals to AB over 7. We will multiply this equation by 7 and we will get that AB equals to 7 times 7 is 49 over 9. AB equals to 49 over 9. You can write here that AB equals to 49 over 9 units. And because of the fact that the opposite sides of a rectangle are equal to each other, it means that AB equals to DC, and if AB equals to 49 over 9, then DC will be also equal to 49 over 9 because they are equal to each other. So in the next step, we will focus on the right triangle, triangle BFC. The lower right triangle, triangle BFC. This right triangle. In the right triangle, triangle BFC, we know that cosine 2 theta equals to FC over 9. In the right triangle, triangle BFC, cosine 2 theta equals to FC over 9. We will multiply this equation by 9 and we will get that FC equals to 9 times cosine 2 theta, and we have that trigonometric identity that states that cosine 2 theta equals to 2 times cosine square theta minus 1, so we can substitute cosine theta, we can substitute cosine 2 theta in this equation by 2 cosine theta minus 1, and we will get that FC equals to 9 times cosine 2 theta equals to 2 times cosine square theta minus 1 according to this trigonometric identity. And we have already found out that cosine theta equals to 7 over 9. Cosine theta equals to 7 over 9, so we can substitute cosine theta in this equation by 7 over 9. We'll do it and we will get that FC equals to 9 times 2 times cosine theta is 7 over 9. If cosine theta is 7 over 9, then cosine square theta will be equal to 7 over 9 square. Here it is minus 1. So we got that FC equals to 9 times 2, 7 square is 49, over 9 square is 81, minus 1. Two times 49 is 98, so I'll write it down. Minus 1 is minus 81 over 81. So we'll substitute minus 1 by minus 81 over 81. That is also equals to minus 1. So FC equals to 9 times 98 minus 81 is 17 over 81. So here we will divide the numerator and the denominator by 9, and we will get that FC equals to 9 over 9 is 1. So in the numerator we left only with 17. And in the denominator we have 81 over 9 is 9. So in conclusion we found out that FC equals to 17 over 9 units. FC equals to 17 over 9 units. So what is the value of DF? You can see from the drawing that DF equals to DC minus FC. Again, DF equals to DC minus FC. I write it down. DF equals to DC minus FC. So DF equals to DC. DC is 49 over 9. And we have already found out that FC is 17 over 9. So DF, in conclusion, equals to 49 minus 17 is 32 over 9. The value of DF is 32 over 9 units. DF equals to 32 over 9 units. So actually we found out all the sides of trapeze ABDF, that is also the green shape. We will calculate the area of the green shape, that is the area of trapeze ABDF. And we know that the area of any trapeze, it equals to the area of trapeze ABDF equals to the sum of its sides, that is to say AB plus DF, times the height is AD, over 2. The area of the green shape, that is also the area of trapeze ABDF, according to the formula for the area of trapeze, it equals to the sum of its sides, that is to say AB plus DF, times the height, that is AD, over 2. And we have already found out that AB is actually 49 over 9. You can see that AB is 49 over 9. Plus DF is 39 over 2. 32 over 9. DF is 32 over 9. Here. Times AD. AD is 56 times square root of 2 over 9. All divided by 2. So in conclusion, we found out that the area of trapeze ABDF, that is also the area of the green shape, equals to 49 over 9 plus 32 over 9 times 52 times square root of 2 over 9, all divided by 2. Okay, so the area of trapeze ABDF, that is also the area of the green shape, will be equal to 49 plus 32 is 81, is divided by 9, times 56 times square root of 2 over 9, divided by 2, okay, so we actually found out that the area of the green shape equals to this expression. Here, 9 times 9 is 81. 81 over 81 is 1, so this expression will get cancelled. And what is left here? Left with this, 56 over 2 is 28 times square root of 2. So the area of trapeze ABDF, that is also the area of the green shape, is equal to either 28 square times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. I repeat again, the area of the green shape, according to the second method, equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the second method. In the next step, I will present to you how to find out the area of this green shape according to a new way, according to the third method. Here we will do a construction From point E, we will draw perpendicular to BF. So this angle will be equal to 90 degrees, and this angle also will be equal to 90 degrees. We will define the touching point between the perpendicular and BF as point M. I will repeat again that all the angles inside the rectangle are right angles, therefore this angle is a right angle. This angle, it is also a right angle, and this is also a right angle, that is to say it equals to 90 degrees. So in the next step we will prove that those two right triangles can go into each other. That is to say, the right triangle, triangle ABE, is congruent to the right triangle, triangle EBF. First of all, we know that those two angles, they are equal to each other, they are both equal to theta, according to what is given us in the question. So we can write down that angle ABE equals to angle EBM and they are both equal to theta according to what is given us in the question. I will repeat again. Angle ABE equals to angle EBM, and they are both equal to theta according to what is given us in the question. And those two angles, they are right angles, therefore they are equal to each other. That is to say, this angle is angle BAE, and it equals to this angle, that is actually angle BME. And both angles are right angles, that is to say they are equal. That is to say they are equal to 90 degrees. I'll repeat again, angle BAE equals to angle BME, and they are both equal to 90 degrees, they are right angles. And those two angles, they are equal to each other according to third angle theorem. I'll write it down. Angle AEB of triangle AB is equal to angle BEM, this angle, and they are equal to each other according to third angle theorem. Again, angle AEB equals to angle BEM according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. Here we found that those two angles in the right triangle, triangle BAE, congruent to those two angles in the right triangle, triangle EBM. So we have two pairs of angles that are congruent in those two triangles, Therefore, the third pair of angles, this pair, must also congruent. That is to say, angle AEB equals to angle BAM according to third angle theorem. Okay, and we also have here a common side BE equals to BE is a common side that belongs to both triangles. So I write it down. BE equals to BE is a common side that belongs to both triangles. So we actually proved that those two triangles congruent to each other according to angle side angle rule. Okay, I write it down. We actually proved the triangle. We proved the triangle ABE congruent to triangle EBM according to angle side angle rule. Okay, and from the fact that those two triangles congruent to each other, we will conclude that AB equals to BM, AB equals to BM, AB equals to BM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say AB and BM will be equal to each other, that is to say AB equals to BM. And if we define AB as Y, that is to say AB equals to Y according to our definition, then BM will be also equal to Y. Okay, AB equals to BM equals to Y. And we can also conclude from the fact that those two triangles congruent to each other that AE equals to EM. AE equals to EM. Okay. AE equals to EM according to the same rule that corresponding sides in congruent triangles are equal to each other. And if we define AE as X, then EM will be also equal to X. You can see it from this equation. So if AE equals to X, then EM will be also equal to X. And we also know that AE equals to ED. It is given us in the question that AE equals to ED. So if AE equals to X, then ED will be also equal to X. Okay, here we know it is given us in the question that BF equals to 9 units and BM equals to Y according to our definition. Therefore, MF will be equal to BF minus BM. That is to say, MF will be equal to BF, that is 9 units, minus BM, that is Y. That is to say, MF will be equal to 9 minus Y. In the next step, we'll join together points A, E, and F by straight line. And we will prove that those two right triangles congruent to each other. Okay, we will prove that this right triangle it is actually EDF congruent to the right triangle, triangle EMF, this triangle. First of all, we know that those two angles they are equal to each other, they are both right angles, so we can write down that angle EDF equals to angle EMF, this angle, and they are both equal to 90 units. I'll repeat again, angle EDF equals to angle EMF, and they are both equal to 90 units, 90 degrees, they are equal to 90 degrees. We have already found out that EM equals to ED equals to X, EM equals to ED equals to X. EM equals to ED equals to X. And we have a common side, EF equals to EF. It is a common side that belongs to both triangles. EF equals to EF is a common side that belongs to both triangles. I'll repeat again, EF equals to EF, it is a common side that belongs to both triangles. So, by proving those three things, we actually proved that those two triangles can congruent to each other according to rule number 5. What is rule number 5? According to rule number 5, if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. And repeat again on rule number 5. According to rule number 5, if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. And here we actually proved that the hypotenuse EF and the perpendicular ED in the right triangle EDF congruent to the hypotenuse EF and the perpendicular EM in the right triangle EMF, Therefore, we proved that those two right triangles can join to each other according to rule number 5. So we can write down that triangle EMF can join to triangle EDF according to rule number 5. I'll repeat again, triangle EMF congruent to triangle EDF according to rule number 5. And from the fact that those two triangles can go into each other, we will conclude that MF equals to DF. MF equals to DF. MF equals to DF according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other. Therefore, the two corresponding sides MF and DF will be equal to each other. That is to say, MF equals to DF. But we know that MF equals to 9 minus Y. MF equals to 9 minus Y. And from this equality, we will get that DF also equals to 9 minus Y. So DF equals to 9 minus Y. We know that the opposite sides of a rectangle are equal to each other. That is to say, AB equals to DC. And AB equals to Y, so DC will be also equal to Y. So DC equals to Y. And what is the value of FC? FC equals to DC minus DF. Again, FC equals to DC minus DF. FC equals to DC minus DF. FC equals to DC minus DF. So FC equals to DC is Y minus DF is 9 minus Y. So we found out that FC equals to Y minus 9 minus Y. We will open the brackets here and we will get that FC equals to Y minus 9 minus Y is plus Y. So FC equals to Y plus Y is 2Y minus 9. So we found out that FC equals to 2Y minus 9. So we can write here that FC equals to 2Y minus 9. So here we note that the opposite sides of a rectangle are equal to each other. That is to say, AD, the opposite sides of a rectangle are equal to each other. That is to say, AD equals to BC. But AD equals to x plus x. AD equals to 2x. Then, therefore, BC will be also equal to 2x. Here, we will focus on the right triangle, triangle ABE. on the right triangle ABE, according to the Pythagoras theorem, x squared plus y squared will be equal to 7 squared. That is to say, x squared plus y squared equals to 49. This will be equation number 1. X squared plus y squared equals to 49. Okay, in the right triangle ABE. I repeat again, in the right triangle ABE, x squared plus y squared equals to 49. We will focus on this right triangle BFC, and in the right triangle BFC, according to the Pythagoras theorem, the square of the hypotenuse is BF squared. BF squared is 9 squared. 9 squared is 81. Will be equal to the sum of the squares of the perpendiculars. That is to say, it will be equal to FC squared. FC is 2y minus 9, so FC squared will be equal to 2y minus 9 squared plus BC squared. BC is 2x, so BC squared is 2x squared. 2x squared is 4x squared. So in conclusion, we found out that according to equation number 2, in the right triangle BFC, 81 equals to 2y minus 9 squared plus 4x squared. We will open the brackets on both sides, on this side of equation number 2, and we will get that 81 equals to 2y minus 9 squared is 4y squared plus 81 minus 36y plus 4x squared. We have here 81 on both sides of equation number 2, therefore 81 will get cancelled. So here we have 0 equals to, we will take a common factor of 4 from 4y squared and 4x squared, and we will get that inside the brackets we will have x squared plus y squared minus 36y. We will add to this equation number 2, 36y, and we will get that 36y equals to 4 times x squared plus y squared. Okay, but we know that according to equation number 1, x squared plus y squared is 49, so we can substitute x squared plus y squared in equation number 2 by 49. Okay, so we'll do it now, and we will get that 36y equals to 4 times x squared plus y squared is 49 according to equation number 1. So in conclusion, we found out that 36y equals to 4 times 49. We divide this equation number 2 by 4, and we will get that according to equation number 2, 36 over 4 is 9, so it is 9y equals to 49. 4 over 4 is 1, so 9y equals to 49. We will divide this equation number 2 by 9, and we will get that y equals to 49 over 9, according to equation number 2. But according to equation number 1, x squared plus y squared equals to 49. So we can actually put the value of y inside y squared. We can put the value of y from equation number 2 in y squared from equation number 1 in this equation. We will do it and we'll get that x squared plus, we'll substitute y by 49 over 9 and we'll square it because it is y squared and it equals to 49. Here we will open, no, here we will subtract 49 over 9 squared from this equation, equation number 1, and we will get that x squared equals to, here 49 is 7 squared minus 49 over 9 squared. Okay? So here we have this equation. Equation number 1 states that x squared equals to 7 squared minus 49 over 9 squared. We will use the algebraic identity that a squared minus b squared equals to a plus b times a minus b in order to simplify this expression, and we will get that. So we have the algebraic identity that states that a squared minus b squared equals to a plus b times a minus b. Here we have only x squared, so b squared is 0. A equals to 7 and b equals to 49 over 9. And we know that a squared minus b squared equals to a plus b times a minus b. So here we have x squared equals to a plus b. A plus b is 7 plus 49 over 9 times a minus b. A minus b is 7 minus 49 over 9. So here we will multiply 7 by 9 and then we will divide it by 9 in order to have a common factor with this expression. And we will get that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. Okay, and so we got that x squared equals to 63 plus 49 is 112 over 9. 63 minus 49 is 14 over 9. 112 is 8 times 14, so we'll substitute 112 in this equation, equation number 1, by 8 times 14. And we will get that according to equation number 1, x squared equals to 112 is 8 times 14 times 14 over 9 times 9. Okay? So we got that in conclusion that x squared equals to 8 times 14 times 14 over 9 times 9. 8 is 2 times 2 times 2, so we'll substitute 8 by 2 times 2 times 2, and we will get that according to equation number 1, x squared equals to 2 times 2 times 2 times 14 times 14 over 9 times 9. Here we will take a root out of this equation number 1, and we will get that x equals to the square root of 2 times 2 times 2 times 14 times 14 over 9 times 9. So here the square root of 2 times 2 is 2, the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9. Inside the root we left only with 2, so in conclusion we got that x equals to 2 times 14 times square root of 2 over 9. 2 times 14 is 28, so in conclusion we found out that x equals to 28 times square root of 2 over 9, and we have already found out that y equals to 49 over 9. Now we can easily find out the area of the green shape, that is also the area of trapeze ABDF. The area of trapeze ABDF, the formula for the area of any trapeze, it is actually is the sum of its sides, that is to say AB plus DF, times the height, that is AD, over 2. That is also the area of the green shape. Again, the area of trapeze ABDF equals to AB plus DF times the height AD over 2. So the area of the green shape, it equals to AB is y plus DF is 9 minus y times AD is 2x, x plus x is 2x over 2. Okay, I will repeat again, the area of the green shape, that is also the area of trapeze ABDF, equals to AB, that is y, plus DF, that is 9 minus y, times AD, that is 2x over 2. Y minus y is 0, 2 over 2 is 1, so here we left only with 9x. The area of trapeze ABDF, that is also the area of the green shape, equals to 9x, but we have already found out that x equals to 28 times square root of 2 over 9. Here 9 over 9 is 1, so 9 will get cancelled. So in conclusion we found out that the area of the green shape equals to 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. That is the area of the green shape. I repeat again, the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. So we finished with method 3. In the next step I will summarize the lecture. Actually we wanted to find out the area of this green shape, and in the first method we did a construction. We extended BE and CD until they meet each other, until they intersect with each other. The intersection point is point P. And we know that the opposite, that is actually CD, that is one side of rectangle ABCD, therefore it is absolutely a straight line. And then we extended the straight line CD by straight line, so CP will be still a straight line. Okay? And then I presented to you rule number 1. According to rule number 1, so we know that CP is a straight line, and according to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So CP is a straight line. And if we focus on this side of the straight line CP at point D, the sum of the angles must be equal to 180 degrees according to rule number 1. So this angle that is defined as angle X plus 90 degrees must be equal to 180 degrees according to rule number 1. Angle X plus 90 degrees must be equal to 180 degrees according to rule number 1. We subtracted 90 degrees from this equality and we got that angle X equals to 90 degrees. So we found out that angle X, this angle equals to 90 degrees, it is a right angle. And we know that the opposite sides of a rectangle are parallel to each other, that is to say AB is parallel to CD. And CP is the same straight line as CD. So if AB is parallel to CD, then AB will be also parallel to CP. So AB is parallel to CP, and we have rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. So here we know that AB is parallel to CP. Those two angles are defined as alternating angles and they are located between the parallel lines AB and CP, therefore they are equal to each other according to rule number 2. That is to say, angle ABE equals to angle EPD according to rule number 2. But it is given us in the question that angle ABE equals to theta. So we can write here that angle AB equals to theta, and from this equality we will get that angle APD also equals to theta. Angle EPD equals to theta. This angle equals to theta. Then we know that all the sides inside the rectangle are right angles, so this angle, and this angle are right angles. Then we actually proved that those two right angles can go into each other. Why they can go into each other? Because you know that angle BAE equals to angle DPE equals to theta. We just right now proved that those two angles are equal to each other. They are both equal to theta. And we also know that those two angles, the right angles, they are equal to 90 degrees. So angle BEA equals to angle BAE equals to angle PDE equals to 90 degrees, and those two angles are also equal to each other. They are vertex angles. Okay, so we proved that all three angles in this right angles can go into all three angles on this right angle, and it is given us in the question that AE equals to ED. And actually AE equals to ED, we proved that triangle ABE can go into triangle EPD according to angle side angle rule. What is angle side angle rule? Angle side angle rule is that if two angles and the side that included between those two angles in one triangle can point correspondingly to two angles in the side that included in another triangle, then the two triangles can point to each other according to angle side angle rule. And we actually proved that those two angles and the side that included between those two angles, that is to say AE, can go in triangle ABE, the green right triangle, can point correspondingly to those two angles and the side that include between those two angles, that is to say AD, in the right triangle EPD. Therefore, we proved that those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that BE equals to EP. BE equals to EP according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say BE and EP, will be equal to each other, that is to say BE equals to EP. But we know that BE equals to 7 units. It is given us in the question. From this equality, we will conclude that EP also equals to 7 units, so EP also equals to 7 units. Then we defined the quadrilateral EBFD as Y. The area of this quadrilateral EBFD is Y. So the area of quadrilateral, the area of quadrilateral EBFD is defined as Y. And then we defined the area of the right green triangle, triangle ABE as X. So as you can see from the drawing, the area of the green shape is equal to X plus Y. The area of the green shape equals to X plus Y. But because of the fact that those two right triangles can go into each other, they also have the same area. So if the area of triangle ABE is X, then the area of triangle PED will be also equal to X. Okay, so the area of triangle PBF, the area of this triangle, will be equal to X plus Y. The area of triangle PBF equals to X plus Y, exactly as the area of the green shape that is also equal to X plus Y. So if we find out the area of triangle PBF, we will find out also the area of the green shape, because they have exactly the same area. This is to say their area is X plus Y. So we'll find out the area of triangle PBF, and in this way we'll find out the area of this green shape. Okay, and we know that the isosceles triangle PBF is an isosceles triangle. Why? Because it has two angles that are equal to each other. Those two angles that are equal to each other, they are both equal to theta. Therefore, triangle PBF is an isosceles triangle. And we have rule number 3. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have the isosceles triangle ABC, this triangle ABC is an isosceles triangle because it has two angles that are equal to each other, they are both equal to each other, therefore triangle ABC is an isosceles triangle. And the base of triangle ABC is BC. From the vertex A, we draw the median AO. The median, according to its definition, bisects side BC. So OB equals to OC equals to X. And according to rule number 3, it is not only bisects the base BC, but it is also perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so rule number 3 states that the median to the base in an isosceles triangle is perpendicular to the base. This triangle is triangle ABC, is an isosceles triangle, and the median AO is perpendicular to the base BC. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So we can actually implement rule number 3 in our drawing, because we have the isosceles triangle PBF, and the median PE, that is bisects the base PB into 2 equal parts. That is to say, BE equals to 7 units and EP also equals to 7 units. But it is not only bisects the base PP, but it is also perpendicular to the base PP. That is to say, this angle equals to 90 degrees and this angle also equal to 90 degrees. And because of the fact that this angle equals to 90 degrees, then triangle EBF is a right triangle. So we can implement the Pythagoras theorem in this right green triangle, triangle EBF, in order to find out the value of EF. That is the only missing side. Okay, so in the right triangle BEF, according to the Pythagoras theorem that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, BF square equals to EF square plus BE square. BF is 9, so BF square will be equal to 81. BE is 7, so BE square will be equal to 49. So BF square is 81, BE square is 49, plus EF square. We subtracted 49 from this equation number 1, and we got that EF square equals to 32. Then we took a root out of this equation number 1, and we get that EF equals to the square root of 32. 32 is 16 times 2, and the square root of 16 is 4, so in conclusion we found out that EF equals to 4 times square root of 32. EF equals to 4 times square root of 2, okay, and we know that the base BP equals to 7 plus 7, 14, therefore we can easily calculate the area of this triangle PBF, that is also the area of the green shape. So the area of the isosceles triangle PBF equals to the base of the triangle times the height to the base over 2. The base is PB, the height is EF, so the base is PB, the height is EF, so it is BP times EF over 2. PB equals to 7 plus 7, that is 14. PB equals to 14, and EF equals to 4 times square root of 2. EF equals to 4 times square root of 2, so PB equals to 14 times 4 times square root of 2 over 2. 14 over 2 is 7, so the area of triangle PBF equals to 7 times 4 times square root of 2. 7 times 4 is 28, so the area of triangle PBF, that is also the green area, equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the first method. Then I presented to you how to find out the area of this green shape according to a second method. According to the second method, here we know that the opposite sides of a rectangle are parallel to each other, that is to say AB is parallel to DC, and if AB is parallel to DC, AB will be parallel to the part of DC, that is to say AB will be also parallel to FC, that is part of DC. So AB is parallel to DC, and we have rule number 2 that alternating angles between parallel lines are equal to each other. Those two angles are defined as alternating angles, and they are located between the parallel lines AB and FC, therefore they are equal to each other. That is to say, this angle, that is theta plus theta, is 2 theta. It equals to this angle, so this angle will be also equal to 2 theta, according to rule number 2. This angle equals to 2 theta, and we know that all the sides, all the angles inside a rectangle are right angles, so this angle, this angle, and this angle will be equal to 90 degrees. Then we focus on the right triangle BAE, and the right triangle BAE actually draw again the right triangle ABE. We defined AE as X, and we know that BE equals to 7. AE is X according to our definition, and B equals to X, and this is angle theta. This is angle theta, so you can see from the drawing that sinus theta equals to X over 7. And if we focus on this, the lower right triangle BFC, you can see that sinus 2 theta equals to 2x over 9. BC equals to 2x because the opposite sides of a rectangle are equal to each other. And AD equals to x plus x, that is to say equals to 2x. And AD is equal to BC, so if AD equals to 2x, then BC will be also equal to 2x, and BF equals to 9. So sinus 2 theta will be equal to 2x over 9. So in triangle BFC, sinus 2 theta equals to 2x over 9. But we have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosine theta. So we can substitute sinus 2 theta in this equation number 2, by 2 sin theta cosine theta. We did it, and we got that 2 sin theta cosine theta according to equation number 2 equals to 2x over 9. But we also know that sin theta equals to x over 7. So we can substitute sin theta in this equation number 2 by x over 7. So we did it, and we got that 2 sin theta is x over 7 times cosine theta equals to 2x over 9. We divided this equation number 2 by 2x. We have 2x on both sides of the equation. And we got that cosine theta over 7 equals to 1 over 9. We multiplied this equation number 2 by 7, and we found out that cosine theta equals to 7 over 9. So we found out that cosine theta equals to 7 over 9. And what is the meaning of this equation that cosine theta equals to 7 over 9? It means that we have a right triangle with hypotenuse of 9 units that equals to 9 units, and the angle that is near angle theta, the side that is near angle theta equals to 7 units, and this is a right triangle. So here the only missing side is the side that is in front of angle theta. We can easily find out the value of S, that is the side that is in front of angle theta, according to the Pythagoras theorem. S square plus 7 square equals to 9 square. S square is 49. 7 square is 49. S square is S square, so 9 square is 81. We subtracted 49 from this equation, and we found out that S square equals to 81 minus 49. 81 minus 49 is 32, so S square equals to 32. We took a root out of this equality, and we found out that S square equals to s equals to the square root of 32, but 32 is 16 times 2, and the square root of 16 is 4. So in conclusion, we found out that s equals to 4 times square root of 2 units. So here we can write down that s equals to 4 times square root of 2, and from here we can also find out, from this drawing we can find out the area and the value of sinus theta. From this drawing we can see that sinus theta equals to 4 times square root of 2 over 9. Sinus theta equals to 4 times square root of 2 over 9. Okay? In conclusion, sinus theta equals to 4 times square root of 2 over 9. And we have already found out that cosine theta equals to 7 over 9. And according to equation number 1 that I presented to you, sinus theta equals to x over 7. You can see it here, that sinus theta equals to x over 7. This is equation number 1. But we have already found out that sinus theta equals to 4 times square root of 2 over 9. So we can substitute sinus theta in equation number 1 by 4 times square root of 2 over 9. We did it and we got that 4 times square root of 2 over 9 equals to x over 7. Then we multiplied this equation number 1 by 7, and we got that x equals to 7 times 4 is 28. X equals to 28 times square root of 2 over 9. So here we can write down that x, AE, that is x, it equals to 28 times square root of 2 over 9, and also here ED equals to x, that is 28 times square root of 2 over 9. And if x equals to 28 times square root of 2 over 9, then 2x, that is AD, will be equal to 56 times square root of 2 over 9. And we know that here also BC equals to 2x, that is to say BC also equals to 56 times square root of 2 over 9. Then we found out the value of AB according to this right triangle. We can see that cosine theta equals to AB over 7. In the right green triangle ABE, cosine theta equals to AB over 7. We multiply, we know that we have already found out that cosine theta equals to 7 over 9, so we can substitute cosine theta by 7 over 9, and we will get that 7 over 9 equals to AB over 7. We multiply this equation by 7, and we got that AB equals to 7 times 7 is 49, so AB equals to 49 over 9. So we found out that AB equals to 49 over 9, but because of the fact that the opposite sides of a rectangle are equal to each other, AB equals to DC, and if AB equals to 49 over 9, then DC will be also equal to 49 over 9. Okay, and then we focus on this right triangle FCB. You can see here that cosine 2 theta equals to FC over 9. Cosine in the right triangle BFC, cosine 2 theta equals to FC over 9. We multiplied this equation by 7, and we found out that FC equals to 9 times cosine 2 theta. We have the trigonometric identity that states that cosine 2 theta equals to 2 cosine square theta minus 1. So we can substitute cosine 2 theta by 2 cosine 2 theta minus 1 according to this trigonometric identity. So we did it, and we got that FC equals to 2 times 2 cosine square theta minus 1. But we know that cosine theta equals to 7 over 9, so we can substitute cosine theta in this equation by 7 over 9. We did it, and we got that FC equals to 9 times 2. If cosine theta equals to 7 over 9, then cosine square theta will be equal to 7 over 9 square. So in conclusion, we found out that FC equals to 9 times 2, 7 over 9 square minus 1. So here we got that FC equals to 9 times, here 7 square is 49 and 8 square is 81. So in conclusion, we got that FC equals to 9 times 2 times 49 over 81 minus 1. Minus 1 is minus 81 over 81. We substituted minus 1 by minus 81 over 81. and we got that FC equals to 9 times 98 minus 81 over 81. 98 minus 81 equals to 17. Okay, so here 98 minus 81 is 17. So in conclusion, we got that FC equals to 9 times 17 over 81. We divided the numerator and the denominator in this side of the equation by 9. 9 over 9 is 1 and 81 over 9 is 9. So in conclusion, we got that FC equals to 17 over 9. So we can write here that FC equals to 17 over 9. And what is the value of df? df equals to dc minus fc. Again, df equals to dc minus fc. Okay, df equals to dc minus fc. But we already found out that dc equals to 49 over 9 and df equals to 17 over 9. df equals to 17 over 9. So df equals to 49 over 9 minus 17 over 9. 49 minus 17 is 32. So in conclusion, we found out that df equals to 32 over 9. Here df equals to 32 over 9. So we have all the sides of trapeze ABDF that is also the area of the green shape. So we can easily find out the area of the of trapeze ABDF that is also the area of the green shape. The area of trapeze ABDF is equal to the sum of its sides, that is to say AB plus DF times the height, that is AD over 2. Again, the area of trapeze ABDF equals to the sum of its sides, that is to say AB plus DF times the height, that is AD over 2. AB is equal to 49 over 9. DF is equal to 32 over 9. So DF equals to 42 over 9. And AD equals to 56 times square root of 2 over 9. So here we got this expression. Here 49 plus 32 is 81. So here we will have 81 over 9. And here we also have 9 in the denominator, so 9 times 9 will be equal to 81. So here we have 81 over 9 times 9, that is also 81. So 81 over 81 is 1. And here 56 over 2 is 28. 56, so 81 over 81 is 1. So this expression will get cancelled. That 56 over 2 is 28. So in conclusion, we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. That was method 3. The first method. Okay, and then we found out the area of the green shape according to the, actually that was the second method. So we found out the area of this green shape according to the second method. Then we found out the area of the green shape according to the third method. The area of the green shape according to the third method, we actually from point E we draw perpendicular to BF, and so this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees, and we define the touching point between the perpendicular and BF as point M, and then we prove that those two right triangles can go into each other. We actually proved the triangle ABE is can go into triangle EBF. Why they can go into each other? Because of the fact that, first of all, we have those two angles that are equal to each other. They are both equal to theta. So angle ABE equals to angle EBM equals to theta. We have those two angles, they are equal to each other, they are both equal to 90 degrees. So angle BAE equals to angle EMB equals to 90 units. And we have those two angles that are equal to each other according to third-angle theorem. So what is third-angle theorem? Third-angle theorem states that if two angles in one triangle can congruent to two angles in another triangle, then the third pair of angles must also congruent. And we found out that those two angles in triangle ABE congruent to those two angles in triangle EBM, so we have two pairs of angles that congruent. Therefore, the third pair of angles must also congruent. That is to say, those two angles must be equal to each other. That is to say, angle AEB equals to angle BM according to third angle theorem. And we also have BE. BE is equal to itself, so BE equals to BE is a common side that belongs to both triangles. So we actually proved that those two right triangles congruent to each other. We proved that triangle ABE is congruent to triangle EBM according to angle side angle rule. And from the fact that those two triangles congruent to each other, we'll conclude that AB equals to BM. AB equals to BM. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say AB and BM, will be equal to each other, that is to say AB equals to BM, and if we define AB as Y, then BM will be also equal to Y. So here AB equals to BM equals to Y, and we can also conclude from the fact that those two triangles congruent to each other that AE equals to EM. AE equals to EM according to the rule that corresponding sides in congruent triangles are equal to each other, and if AE equals to X, then EM will be also equal to X. Okay, so AE equals to EM equals to X, then we join together points E and F by a straight line, and we proved that those two right triangles congruent to each other. Why they congruent to each other? First of all, we know that angle EDP equals to angle EMF equals to 90 degrees. Those two angles, they are equal to each other and they are both equal to 90 degrees. And we also know that EM equals to EF. We also know that EM equals to ED equals to X. So EM equals to ED equals to X. And EP equals EF equals to EF as a common side which belongs to both triangles. Okay, so we actually proved that those two triangles, those two right triangles congruent to each other according to rule number 5. And what is rule number 5? Rule number 5 states that if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. And we actually proved that the hypotenuse EF and the perpendicular ED in the right triangle EDF congruent to the hypotenuse EF and the perpendicular EM in the right triangle EMF. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. Okay? Triangle EMF congruent to triangle EDF according to rule number 5. Then we can conclude from the fact that those two triangles congruent to each other that MF equals to DF. MF equals to DF according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides MF and DF will be equal to each other. And we know that MF equals to 9 minus Y. So DF will be also equal to 9 minus Y. From this equality we will get that DF also equals to 9 minus Y. So here DF equals to 9 minus Y. We know that AB equals to DC because opposite sides of a rectangle are equal to each other, and if AB equals to y, then DC will be also equal to y. And what is the value of DF? DF equals to DC minus FC. Okay? Or here, actually, we found that FC equals to DC here DFC equals to DC minus DF. Again, FC equals to DC minus DF. FC equals to DC minus DF. And we found out that we already found out that DC equals to y and DF equals to 9 minus y. So FC equals to y minus 9 minus y. We open the brackets and we got that FC equals to y minus 9, and minus y is plus y. So in conclusion, we found out that FC equals to 2y minus 9. FC equals to 2y minus 9. Here, FC equals to 2y minus 9. And here we know that AD equals to BC. The opposite sides of a rectangle are equal to each other. So if AD is 2x, then BC will be also equal to 2x. And then we focused on the right triangle ABE. According to the Pythagoras theorem, x squared plus y squared will be equal to 7 squared. That is to say, x squared plus y squared equals to 49. X squared plus y squared equals to 49 according to equation number 1. And then we focused on this right triangle BFC. According to the Pythagoras theorem, the square of the hypotenuse equal to the sum of the surface of the perpendiculars. The hypotenuse is BF, so the square of the hypotenuse is BF square. BF square is 9 square. 9 square is 81. So 81 equals to CF square plus BC square. And CF square is 2y minus 9 square. And BC square is 2x squared, that is 4x squared. So in conclusion, we got that 81 equals to 2y minus 9 squared plus 4x squared. So we open the brackets on this side of equation number 2, and we got that 81 equals to 4y squared plus 81 minus 46y plus 4x squared. We have 81 on both sides of equation number 2, so 81 will get cancelled. So we got 0 equals to, we took a common factor from 4y squared and 4x squared, and we got that 0 equals to 4 times x squared plus y squared minus 36y. According to equation number 1, x squared plus y squared is 49. So we can substitute x squared plus y squared from equation number 2 by 49. We did it and we got that 36y equals to 4 times 49. We divided equation number 2 by 4 and we got that 36 over 4 is 9. So in conclusion, we got that 9y equals to 49. We divided equation number 2 by 9 and we got that y equals to 49 over 9. And according to equation number 1, x squared plus y squared equals to 49. So we can substitute y squared in this equation number 1 by 49 over 9 from equation number 2, because y equals to 49 over 9. We did it and we got that x squared equals to y is 49 over 9, so y squared will be equal to 49 over 9 squared, that equals to 49. And then we subtracted 49 over 9 squared from this equation number 1. And 49 is 7 squared, so in conclusion we got that x squared equals to 7 squared minus 49 over 9 squared. And we use the algebraic identity that a squared minus b squared equals to a plus b times a minus b. Here b squared is 0, a equals to 7 and b equals to 49 over 9. So x squared equals to a plus b is 7 plus 49 over 9, and a minus b is 7 minus 49 over 9. Then we multiplied 7 by 9 and then we divided it by 9 in order to have a common factor of 49 over 9. So we got here that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. 63 plus 49 is 112 and 63 minus 49 is 14. Then we substituted 112 by 8 times 14 and we got that x squared equals to 8 times 14 over 9 times 9. And then we substituted 8 by 2 times 2 times 2 and we got this expression. We took a root out of this expression and we got that x, the square root of 2 times 2 is 2, the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9. So in conclusion we got that x equals to 2 times 14 over 9, and inside the root we left only with 2. So x equals to 2 times 14 over 9 times square root of 2. So 2 times 14 is 28. So in conclusion we got that x equals to 28 times square root of 2 over 9 and y equals to 49 over 9. Then we can easily find out the area of this green shape, that is also the area of trapeze ABDF. It equals to the sum, the area of the trapeze, it equals to the sum of its sides, that is to say AB plus DF times the height, that is AD over 2. Okay, the area of trapeze ABDF equals to AB plus DF times AD, that is the height over 2. AB equals to y. AB equals to y, and DF equals to 9 minus y, so AB equals to y, DF equals to 9 minus y, y minus y is 0, so we left only with 9 here, and 2 over 2 is 1, so we left only with 9x. That the area of trapeze ABDF, that is also the area of the green shape, equals to 9x. But we have already found out that the x equals to 28 times square root of 2 over 9. Here 9 over 9 is 1, so in conclusion we found out that the area of the green shape equals to either 28 times square root of 2 square units, so in terms of numbers it equals to 39.6 square units. Okay, thank you very much.